Namaskar. I welcome all of you for online CTET training program. And I am K. Madhu from RI Mysore. And today our topic is aims and objectives of teaching science. Okay, so we'll be focusing on how the CTET questions will be in this topic and what kind of questions they ask and on what topics they are asking and emphasizing more. Right? So we'll try to understand that. So if you can see here, there are different topics given on a priority basis. What CTET prioritizes in this topic. Aims and objectives is the most priority topic inside this aims and objectives topic. Then we have NCF 2005 and NEP 2020 recommendations. There are also a lot of priority is given with respect to questions asked. Then Bloom's taxonomy and its verbs. And it also talks about the other dimensions also, affective domain and also psychomotor domain. Then activity based encourage pedagogy, for example, like these come under methods of teaching science. So methods of teaching science at different levels is also given emphasis. Then upper primary red flags and so these are the different major areas where question can come under this topic. So let us quickly just go through about the concept of aims, goals, objectives and outcomes. Only if we understand these, whatever the questions related to aims and objectives, we will be able to solve properly. So we need to have a better understanding about these. So what are aims, what are goals, objectives and outcomes? Are they similar? If they are different, how they are different? Which is broader in nature, which is specific in nature. So in this context, if we talk aims, are the very broader ones which are given nationwide, okay, for with respect to including all the subjects. Okay, aims are the broadest ones, and next, according to the aims, based on aims, then goals will come from aims. Goals will come which are specific to subject. Then we have objectives specific to the lessons or the chapters that we'll have inside the textbook. Then we have outcomes which will be which will be met at the end of the lesson. So aims at the topmost, aims at the top level, then goals. Based on aims we have goals, and then objectives, then outcomes. So the specificity increases from top to bottom. So if in that context, aims are the broadest ones and objectives are very specific, and outcomes will be met based on the objectives. So let us understand what kind of questions will be asked from this topic. What kind of questions means how they will be asked, and how like it will be difficult for you and where you might face difficulty in the questions from this topic. Like the first type of question is, what is not an aim of science? So what is not an aim of science? What is the aim of science, or what is the goal of science, or what are the objectives? So questions will be of this sort with respect to this topic, this subtopic in aims and objectives. Like if we can see here an example question from 2015, which of the following should not be an aim of science? They're asking which of the following should not be an aim of science. Okay, so this is one type of question. There are other questions also you can see here. There is one more question. There are two more questions from 2014 and 15, which is not a desirable aim of science education in the upper primary level. And the next question is, which is not a desirable objective of learning science at upper primary level. Both look similar, but they are asked in a different way with different options that are given. Like that. So one is in 2015 and 14. So this is how the questions will be asked with respect to the objectives of science. Okay. So if we can just go through the options, which is not the following. Which of the following should not be an aim of science education at primary level? It is merely presenting facts of science and learners. That is not the aim. Okay. The rest of the options, if we see, inculcating values, definitely. Okay, relating science to everyday experiences, that is also an aim. Nurturing curiosity and cultivating scientific temper, this is also an aim. So what is not the aim here? Merely presenting facts on science, because science, if you can see the science aims, these are the aims of science. Okay, so you'll understand here what are the aims of science. It is utilitarian. Okay, it should be useful in our everyday life. Then intellectual, it should be able to develop the intellectual ability of the students. Then disciplinary, the discipline specific knowledge should be enhanced. with respect to science. Then cultural, okay, then moral aims are also there. It should, it should have proper moral values that are necessary inside this, culture, this is society. Aesthetic aims, psychological, scientific attitude. So I will talk little later in depth about what scientific attitude. Then social and vocational. So these are the different aims that is, school science will have usually. So I hope now you can understand how the questions can be asked from this topic. The other two also we discussed here, which is not a desirable aim, which is not a desirable aim, or identify an appropriate aim from the school science, or identify an appropriate aim that is suitable for upper primary level, or primary, or middle stage, or secondary stage. This is how questions can be asked. So for that if you want to solve all these kind of questions, you should be very clear with the objectives, the science objectives in general, and also stage specific objectives. Stage specific, I mean upper primary level objectives, then what are the secondary level objectives, middle stage objectives, senior secondary objectives. So we should be familiar with those objectives, then those aims, then we'll be able to solve these kind of questions. So this is about upper primary level of objectives. So stage wise are also given here: lower primary, upper primary, secondary, senior secondary. There is a small correction that we can make here. So according to NAP 2020, the upper primary stage, that is from 6 to 8, we call it as middle stage. Okay. So it is also it is called as middle stage, and that is the term that we need to use since the policy emphasize like that. Okay, so and at lower stage we already discussed in our when we were discussing about nature of science, we discussed how science should be at different levels. So if you can see the primary level, it is EVS, the integrated one. Then upper primary level, it is an independent subject, and it is experiential based in nature. Okay, when you come to secondary, it becomes composite, very specific, the physics, chemistry, biology, divided, science, it is divided into physics, chemistry, biology in composite nature. Then senior secondary, it becomes even more depth with including vocational and competitive readiness. So these are the different levels of objectives, stage-wise objectives from 1 to 12. Then upper primary research work. So this is also related to the aims related to upper primary. So if we can go through this question, is from 2012. When upper grade children do research work, the major problem a teacher has to contend with. Okay, when a teacher is dealing with upper primary students, and what problem he or she might face. Okay, so gaining cooperation of the public library, finding appropriate materials, scheduling library or internet time. So the right answer is discouraging verbatim copying and guiding inquiry. So guiding inquiry is the major challenge that a teacher might face in a science class at upper primary level, because all other things like cooperating and asking for public library, then finding materials and internet facilities, all these are fine. But in the classroom, encouraging and promoting a guided inquiry, inquiry in the sense investigation or experimentation is little challenging. Okay. So then again we'll have questions from Bloom's taxonomy, Bloom's verbs, okay, which comes into cognitive domain of learning, right? So this is from 2019, question from 2019 regarding Bloom's verbs and Bloom's taxonomy. So it's the question is, in conducting a survey on awareness of air pollution sources, the verb conducting maps to which cognitive process? The questions will be like, okay, they'll give a scenario like conducting a survey or doing something or performing an activity, differentiating between something. So these verbs like conducting or differentiating or analyzing, using. So these kind of verbs they'll give, and they'll ask you to map into the Bloom's taxonomy levels. Like we'll see what are those levels. Like if we can see here, in this slide. Bloom's cognitive domain. Okay, the right side we have the revised one, and the left side we have the previous one, which is revised and given, updated and given. So let us focus on the right side one. We have different levels of learning here at cognitive domain. Remembering, if you see from down, remembering, understanding, applying, analyzing, evaluating and creating. Like, whereas if you see the left side, the previous one, there is a difference. If you see the top two levels, there is a change in top two levels. L5, that is L5. In L5 you can see, okay, L5 and L6, there is a change. What is the change? So there was a synthesis at level 5 in the the older version of it, then evaluation at the topmost. Whereas if you see when progression happened, the change is evaluation became L5. Evaluation came to level 5, then creating went to level 6. Okay, this is the major change that had happened in the revised Bloom's taxonomy. This is in 2001 and this is 1956. So how they will ask questions with respect to this. So they might give you a few instances like conducting a survey, while differentiating something, while performing an activity. These kind of questions they may ask, and whatever the verb they give, like here the verb is conducting. We'll also discuss about different kinds of verbs that come under different domains of Bloom's taxonomy, right? So then you will have a better understanding. So like this, they will give a scenario or a situation where there is a verb, and they'll ask you to map those verbs into the different levels of Bloom's taxonomy. So conducting is applying. It's not just remembering, it is not remembering, it is not understanding, it is not creating. Why? Because conducting requires a little higher order thinking process. Okay, so remember is just basic remembering, understanding is finding meaning, meaning making out of something and all. So these two are called as lower order. So remembering, understanding, little lower order skills, lower order thinking skills, and all the three, they are higher order. Okay, so remember this, and they might ask you to just identify, map the words into different levels. So higher order thinking, one more question is from 2019. Which of the following can best enhance critical thinking among children? This is one more type of question. Which of the following can best enhance critical thinking among children? So first option is teacher demonstration of experiments, reading the science textbooks in class, and reading the extended learning at chapter end. Then fourth is group discussion, then whole class sharing. So now we have discussed, right, applying, analyzing, evaluating, creating. So they are asking which will enhance the higher order, which will best increase or enhance critical thinking. Critical thinking is higher order thinking. So which one among these will develop critical thinking? It is definitely group discussion, then whole class sharing, because a lot of discussion, a lot of knowing different perspectives, encountering different arguments, all this happens, and a constructive argument takes place in group discussions and whole class sharing. So that will help for enhancing critical thinking. Whereas others, teacher demonstration, students may just listen and passively listen to that. Reading a science textbook can also happen passively, even if they are doing actively. But what develops critical thinking is the discussion part, where you come across the perspectives, different ideas, argumentation, all that happens in group discussion. So that's why the fourth answer is right. Then cognition and emotion. So the question is about cognition and emotion. So cognition we have talked, which was talked by Bloom, and he gave the different levels of learning under cognitive domain. So there are other two domains also, as all of you know. So affective domain and psychomotor domain. Affective domain is related to our feelings, right? Cognitive is the thought process. If you can see, remembering, understanding, applying, analyzing, all these are mental process, the thought process that happens in the brain, right? So whereas affective means what we feel, what we feel, our emotions, our attitudes, our values, that come under affective domain. Then psychomotor means where our body parts are involved, where we manipulate things, where we perform something physically and manual skills. Okay, these come under psychomotor skills. Like for example, if you can see affective, we have receiving. How do we receive things? Willing to attend. Okay, examples are willing to attend, listening to a demo, responding. How do we respond to what we listen, and how do we respond to different situations? Valuing. What are your values? How do you value something? A concept was taught to you. What kind of value do you have towards the concept? What kind of value that you have in a society related to the topic or related to a biological organism and all. Then organization, these are not emphasized much comparatively to cognitive domain. Cognitive domain will be having more emphasis in CTET, but whereas these two also have emphasis, there are little less questions will be there from these two, affective domain and psychomotor domain, but major focus on cognitive domain. So when it comes to psychomotor, there are skills, manual skills and physical skills like imitation. When teacher demonstrates something, you do the same. When teacher asks you to perform an experiment by showing or by demonstration, you also perform, seeing watching the teacher. So this is what imitation. Then manipulation, follows written steps independently. Precision, how precisely are we doing? How precisely are we collecting the information, recording it? How precisely we are handling the apparatus? Then articulation, how will we combine all these skills and talk about it, coordinate it. Then naturalization. Okay, so these are the different domains, cognitive, affective, psychomotor. So when you're preparing, focus more on cognitive domain because questions will be more from cognitive domain, but there are questions from affective and psychomotor domain also. But yeah, okay, little less comparative to cognitive domain. So remember this difference. Even the difference between the revised Bloom's taxonomy and the Bloom's taxonomy is also emphasized in CTET questions. Like they will ask you what is the change between the original taxonomy and the revised Bloom's taxonomy. So what change happened? Where change happened? And change happened in which learning stages the change happened. So all these questions will be there. Other two domains, then engagement and interest applied. So the questions also will be asked about the teaching learning process where the students' engagement and their interest is emphasized. So the CTET questions will also ask which method or which strategy or which teaching learning process or what kind of teaching learning process is best for improving or enhancing students' engagement or interest. So these kind of questions will be there. So for example, we can see a few questions from previous year. Which strategy is most appropriate for involving learners in science teaching? So they are asking most important for involving learners. So if you can see the options, encouraging group assessment, reading a science book, clarifying hard spots for learners, then working in engaging the learning first. So what will be most suitable here? Most appropriate for involving learners. Involvement. So we can directly connect to the fourth one. That is, there is a word called engaging in the fourth option. Working on engaging the learners first. So when they are engaged, the focus is given. When the focus is given to engaging first, then definitely their involvement will be more, and engagement will definitely enhance their curiosity and interest. Then next question is from 2022. The example question. Which is an appropriate objective for organizing a science fair in school? That means when you are actually organizing a science fair, what will be your objective? What will be your objective behind organizing this? Options are good publicity for the school. Second option, increasing students' interest in science, meeting administrative requirements, developing a feeling of competition. So the most suitable one is it is for increasing students' interest in science, because the aim, the objectives for science will be related to the science learning of different domains, whether it is cognitive, affective, or psychomotor. Here, increasing students' interest means it is related to the affective domain part of it. Okay, so the Right answer is increasing students' interest in science. Whereas good publicity for school, no, we don't organize science fairs to increase our publicity, to increase schools' publicity. For for that purpose, there are different there are different activities that a school does. But while for science fair, the objective is related to the science itself, to improve or to enhance the interest in science. Meeting the administrative requirements, no. Then developing a feeling of competition, not at all. Okay. Yeah, best method for young learners. So what the like we discussed, right? Like at upper primary level, what is the best strategy? What is the best method to teach certain concept? What is the best method to improve their improve the critical thinking or engagement or interest, whatever it is. So this is one of the question. Hari wants to teach a circular motion in class 6th. Okay, class 6 students. Which method will be best for teaching circular motion in a class? So is it activity based, just giving examples, or is it a demonstration and discussion? The right option is activity based, because there are a lot of, in activity based, a lot of involvement is there from the student side. There is a cognitive involvement, there is an affective involvement because they will be performing an activity in groups and all. Then there is a psychomotor involvement also. All the three domains are involved in activity based, because when you do activity, you are also using your body parts, you are performing something, you are exhibiting your physical and manual skills. Okay, so as all these domains are involved, so it will be more appropriate to teach any concept, to be frank, but in this question it is asked motion in class 6. Whereas giving examples, just they will have to remember. You teach definition of motion and you just give examples, it becomes just memorization. Only the cognitive domain is involved there. And demonstration, again, they just watch the demonstration and they try to understand. And again, it will be mostly remembering, and it will go to only remembering and understanding level of Bloom's taxonomy, but not application and all. Okay. Then discussion also helps because there is a lot of idea generation there, different perspectives and all. That is also better for teaching circular motion. But what is best is activity based. Okay. So sometimes the options will be so convincing to you, other options also will be convincing to you, but you have to choose the best one. And it is also asked in the question that which method will be best, so and so thing that they asked. Okay. Why hands-on activity of Piaget? So this also talks about concrete, pictorial and abstract. So for better engagement, for better for encouraging, for developing interest, for critical thinking and all, concrete, pictorial and abstract, these are very important. So manipulating, performing with models, diagrams, representation, symbols and formulas. So the more the engagement, the more the domains that are involved in the learning process, not only confining to cognitive or psychomotor or this thing. So when all these are together, we do any activity or any teaching learning process involves all these three, the learning will be more concrete. Okay. So with respect to the concrete experience, and we also discussed one more thing when we talked about the middle stage. Science is more experiential in nature. Science should be taught in experience, in a way of through experience. That's what we discussed. So how a experience can be concrete. So this is one more thing where focus will be there from the CTET. Okay, so we'll see the example questions. So from 2012, this question is in a mixed ability class, varying cognitive stages. Which strategy is more suitable? Okay, individual instruction for gifted students only. The average IQ scores and plan accordingly. Average IQ scores and plan accordingly. Then third one is hands-on activities with concrete objects, regroup into 4 Piaget stage groups. So the most appropriate one is hands-on activities, as we discussed just earlier, that it involves a lot of domains of learning. All the 3 domains will be involved, and it will be more, more suitable, for a mixed classroom, for any classroom, to be frank. Okay, then there is one more question here, 2019 question. Okay, so we'll move forward. We'll just let us discuss only one single question from topic, so that we cover almost all the topics. So NCF 2005, we also spoke NCF 2005 recommendations, what NCF 2005 talks about science education, the characteristic of science education, the objectives of science education is also very important. The question is about, so first let's see what NCF 2005 and one NCF NEP 2020 recommendations are related to science education. If you can see in the left side, we have connecting learning to life outside. So I'll just, and wherever I'm underlining, just focus there. There the that is the emphasis, okay, that is played. So connecting to real life, okay, then reducing memorization, that is one more thing. So it is majorly focused on understanding and inquiry. Then activity oriented, learner centered. This is the very important topic which everybody should, all of you should remember. It is activity oriented, learner centered teaching, which is majorly emphasized by NEP 2005. Then emphasis on process skills, observing, classifying, experimenting, okay, the methods of the process skills that are required in knowledge generation in science. Then doing experiments at upper primary level. Then curriculum which is related to the local context. So these are very important, and these are the recommendations, the major recommendations towards science education. So NEP 2020 recommendations are also there. They are little general, but then let us just see them also. Bilingual text teaching materials, vocational crafts, then curriculum rooted in, again that is repeated, rooted in local context, scientific temper, experiential, activity based, all these things. So the example question from NCF 2005 recommendations is, this question is from 2014. Okay, NCF 2005 recommends that science education at the different upper primary should focus on. Again, it is related to the objectives of upper primary stage with respect to science. So is it connecting classroom learning to life outside school, acquiring international standards in science, then minimum social disparities among students, then promoting human values for peaceful society. So as we saw, connecting learning to life is the first and foremost, okay, objective of science according to the recommendations of NCF 2005. The correct option is this. So acquiring international standards in science and minimizing social disparities, promoting human values for peaceful, that they are very general, not so specific to the science education. They are also important, but specific to the science education. Then policy contradictions. The questions also will be asked, like which is not aligned with the recommendations of the NCF 2005, or which of the objective is not aligned with the recommendations of NEP 2020 and all. So these kind of questions also will be asked. So the two questions you can see here from 2022. So which is not aligned with NCF 2005 recommendations for upper primary science. Okay, that is one question. The other question, which is not in consens with NEP 2020 recommendation for science pedagogy. So these kind of questions will be asked. The contradicting statements or questions that are not aligning from policy. Then scientific attitude, there are 8 traits, 8 characteristics of scientific attitude: open-mindedness, key observation, critical thinking, suspended judgment, freedom to bias, curiosity. So like I just remember these names, so that whenever there is term like scientific attitude inside in question, you just have to remember these terminologies: open-mindedness, okay, keen observation, critical thinking, judgment, bias, curiosity, objectivity, rational thinking. So these terms please remember, and whenever there is a question related to scientific attitude, or there is a word scientific attitude inside the question, you just have to remember, keep looking for these kind of terms in the options. So Bloom's taxonomy, okay, as we discussed little earlier, so they will ask you to map the scenario or a verb into different levels of Bloom's taxonomy. And Bloom's taxonomy, we have discussed 6 stages in the revised one, and even the previous one also has the 6 stages, but the difference also we spoke, right? So when we see here they have given from lower order to higher order. So remembering and understanding are lower order. Okay, all these are higher order. So what are the, if you can see, there is a level. First column is about level, at the level of Bloom's stage of different Bloom's taxonomy. Second one is signal action verbs that can come under that level, and the science example that is given. So at lower level, at lower order level, remembering and understanding will be there. At remembering, the verbs like define, list, name, recall, identify. So you can just go through the table here, and understanding. Under understanding, the verbs will be like explain, summarize, classify, interpret. So in defining, listing, naming, recalling, identifying, it's just the mere remembering. Okay, they just remember from their previous knowledge or previous experience, and they will be able to tell you. That is just mere remembering. And when it comes to understanding, so when will a student be able to explain or summarize or classify or interpret something about any topic? When they have a proper understanding of it. So it requires an understanding level of, understanding level, not only, only if they remember simple statements and definitions, they won't be able to explain and summarize. So understanding level is very important for these kind of verbs. Then under applying, we have use, solve, demonstrate, conduct and all. Then analysis, compare, distinguish, examine. So whenever these action verbs you see in a question, and if they want, and they ask you to map, so we can map into the specific that particular learning level of Bloom's taxonomy. Okay, so we'll move forward and spot the planted statement. So when we so again, we last class also in nature and scope of science, we discussed how we'll be falling into traps, and how we'll be attracted to the catchy statements and so convenient statements, and you'll straight away going and answering those statements. So be careful, and there are such a certain kind of statements from the CTET papers in this topic also. Let us see few of them, right? So aim is equal to performing better in exams. So usually just it is general, people can have people will be thinking, naturally they think, okay, aim is getting marks, performing better in marks. No. What is the aim of science according to the NCF, NEP, and what do they talk about scientific aims? Aims means not the general aims that we keep with respect to exams or not. So what is the aim of this thing? So when suddenly you see performing better in exams, you shouldn't go, try, opting that exam. So aims are visionary, not exam centric. That we should remember. Then next one is memorizing content in learning aim. Okay, memorizing content in learning aim. No, so it is. It's about building inquiry and understanding. Then presenting facts is not enough. Okay, just when you see presenting facts, shouldn't be convinced. It's about investigation, reasoning, application and all. Technology skills at the upper primary stage. So technology skills are not emphasized, or not technological skills is not the objective of upper primary level, where it comes in the later stages. It belongs to secondary stage. Okay, evaluation is highest in revised Bloom. Okay, so creating is the highest. So evaluation is the highest in revised Bloom's taxonomy, where that is in the not revised one, the first version of the cognitive learning stages. Whereas in revised Bloom's taxonomy, it is creating. The word create is the final, created at the final stage. Vocational crafts from senior secondary, NEP 20 middle school. Okay. So so these are the different. Let us go back and see once again. Yeah. So we saw different topics, right, where they will be focusing more. So let us go through them and let us link few. Yes, aims and objectives, NCF 2005, Bloom's taxonomy, activity based, and different methods and best strategies, and the different objectives at different stages. So these, you remember these topics, and related to those topics, let us revise, let us remember few statements so that you can remember properly. Yeah. So 6 lines that you win the marks. The most important things that you have to remember in this topic: aim is equal to visionary, objective is measurable. Okay, just connect the terms. Aim connect with visionary, objective to measurable, observable, time bound, student centered and all. Then 10 aims exist. Okay, but rote and exam preparation are never valid aims. So when you see something like rote memorization or exam preparation or competitiveness, you have to directly exclude them, because there won't be any exam centric aims. It is purely from science learning and the process skills and scientific attitude, temper and all. Then Bloom 2001, creating at the top level, the shift that happened from previous levels to the latest level. Synthesis came to the top level, whereas previously evaluation was at the top. Okay, then concrete. So the experience or the teaching learning process should be able to help the students to develop a concrete understanding, which is again which should be hands-on activity, where all domains will be involved. Okay, then upper primary level process skills are emphasized: literacy, inquiry. Okay, discourage copying and rating. Okay, NCF, when you talk about NCF, when there is a question about NCF, it is related to connecting to life, doing experiments, child centric, student centric, avoiding rote memorization and all. So NEP means vocational from middle school. So these are the few things that you will have to suddenly, you have to remember just like that when you see few terms like aim, Bloom's taxonomy, different strategies, upper primary level, NCF and all. So with this, we'll conclude our session. I hope you understood what kind of questions will be asked from CTET and what are the topics where they are focusing more and what kind of questions they are asking. Like for example, we discussed about aims and objectives. They were asking to identify the aim, which is not the aim, these kind of questions. And when it comes to methods and strategies, which is the best aim that is suitable for teaching something. Then mapping action verbs to different the levels of Bloom's taxonomy. Okay, then when it comes to objectives at different levels of different stages of teaching, different stages of learning. What about the primary level, upper primary level, middle stage, then secondary, senior secondary. So these will be focused like this. So I hope you remember that, and thank you so much. We'll end this session here. Thank you so much.